Howdy, everybody in YouTube land. So, we are on to the next installment of the series. So, what I wanted to do, I wanted to preface this video with doing some checks in the vertical circuit. So, this chassis is plugged into the wall, it's hot, and I got my probe just kind of laying there. So, we're going to kick the power on. And what I'm going to do is I'm going to test this circuit right here. Remember all of these three caps I had to put at this point right there? There's also a 3.3 meg ohm resistor here, and it goes back to this control. And there should be 100 and some odd volts sitting on that control. So I'm going to turn the power on here. And it could be the output tube, I do not know. So I want to make this quick because I don't like running it with these original electrolytics. So alright, so we're going to check this control here. What do we get? 128 volts. Let's check the other control. They're in 120. Okay, so we have that. So let's check down here at this point. 128. And let's check here at this point. Nothing. Nothing at all. So, cut the power. Alright, so that tells me we're getting a 100 volt drop across that 3.3 meg resistor, which not normal. Now, I remember testing this resistor and it didn't seem to be bad. I'm just kind of waiting for it to discharge. Caps are holding really well. So, I might be able to get some time on these original caps. I don't want to. I want to change them, but in theory, once I fix this, besides the tuner situation, IF strip situation, I should get a full raster. So, alright, well, should be safe to operate on. So, let's see, ohms. Let's figure out why that. Yeah, nope. Yeah, I don't remember it being open like that. But it certainly is. That sucker's open. Okay. Well, let me go dig through my stash of resistors over here and tack one in. Alright, so here we go. I've already got that tacked in there. Let's see what happens. It either works or it burns up. We'll see. Yes, I got vertical. I got vertical. Sort of. But it does work. Yay. So there we go. Now we're getting somewhere. So we saw that we restored the vertical deflection circuit, but we all had that weird black bar in the middle of the screen, which looks like a hum bar. So I just pulled out the capacitor meter. So we are going to test the capacitors here, these filters, which they got to be changed anyway, but let's take a look and see. And the results are not going to be accurate, of course. So check that one. That one's okay. Check this one. That one's like not open, at least. I'm looking for things that are open. Let's see, that one. It's not open. And then we have one here. Let's check that. I'm just literally just between the terminals and ground. Not open. Alright, let's move on to the next one. This is a lug that I soldered earlier, so let's check this one since it's right here. Well, that might as well be open, because I believe that's supposed to be a 40, or no, it might be a 20. Yeah, I think that's supposed to be a 20 or 25. Yeah, that's open. Let's check the one next to it. Next to it. open. Yep, that's open, completely open. Check this one. Cross this resistor. Open. So the middle filter is bad. Yeah, the middle filter's got to be changed. Come on. Trying to do this from ground is like... Yeah, I'm trying to get in here and do this. Yeah, open. So that filter's open. This is why we have our hum bars. This one runs right to the vertical circuit, I'm pretty sure. No, this is horizontal. Never mind. So that one's open. It's got to be replaced. Alright, so let's check this one, which this is a ground point right here. We'll check between here and here. That one's fine. Do the same thing with the next lug over. That one's fine. Let's see, where else do I have another lug? I have one right here. So I can go between here and here. I'm not able to get a reading. Probably because it's too big. Or there's too many resistances on it. Nope, there we go. 25. Yep, that's good. Alright, so all these, this can's still fine. Almost. Trying to do this. Yeah, I'm trying to get that in there. This is not easy to finagle. Is that the ground? Yeah, that's the ground. Yeah, that one might be open. Yeah. So I got one that's open. And then that one's pretty much open. So 3 of the 4 are good in that one. All of these are good and that one's open. But they all got to go. So that's the next item on our list is we need to replace the capacitors in the filter can section. So that's next. And then I'm waiting on the rest of those caps to get here. I'm waiting on terminal strips. And I'm waiting on this control to come in. So, waiting on parts. So, stand by. Alright, so what I'm doing at the moment, not only am I going to put this on YouTube, but I'm also going to keep this for my own documentation so I remember how these wires go. So, this is when it's open, but I need to change them all. So, right now I have on this lug, which is this square lug. The square lug has one wire on it, which is a yellow wire that goes, all the way down here to the audio tube. So that's probably a bypass cap. So square goes the audio tube. Then this one here. Here. That looks like triangle. No, I can't tell. That ain't square. No, that ain't square. That's nothing. That's nothing. That's a blank. That one is... That one's triangle. So triangle goes to one side of a 15K resistor and a wire, which goes to this one here. Which also goes to the audio tube. So that goes the plate. So that goes the plate. That goes the cathode to the audio tube. Then on the other side of this 15K resistor, we have 2 wires coming in. Wire number 1 has this purplish red whatever stripe on it, which goes down to the audio output as well, which is weird. Goes to that cap there at 472. So we have that. Alright, so this is the red one. So we've got 3 there. We got 1 here, 1 there, and 1 here. Alright, so all 3 of those go to there. So that goes to the tube. That goes to the audio tube. That goes to the audio tube. So does this one. And then we also have a wire coming in from here, which is coming off of this sand resistor. So this cap, all 3 of these are dedicated to the audio circuit. All 3 of these. So we have that, and then we have a 4th lug here, which is the, oh, I can't tell. Looks like the circle lug. Yeah, circle lug. So that's the half circle lug. So that's nothing, triangle, square. And then the circle lug we've got going to the new cap we just put in, another 10K resistor, and a red wire that goes up to here somewhere. Red wire. So goes that red wire there. It also goes to another red wire, which ends up over here somewhere. It goes to a red wire, which is right here. So this wire here goes to this pin. So that pin, resistor, cap, and then another red wire that goes up there. So that one goes there. Now this one, this lug here, oh, I can't tell what it is. It looks like it's an unlabeled one. So this is the empty one. That goes off to this control right here. And a 680 ohm resistor to ground. So there's that one. The one next to that appears to be the half circle. So the half circle goes to the 2 black wires. And that's it. And then the square lug goes to this red white wire and this resistor I put in. And that's the only place it goes. And then this one goes to a 100 ohm resistor here. Goes to this wire there, which is heading over to IF strip. So that's going to the IF strip. So that goes to the IF strip, 100 ohm resistor, a little, there's a capacitor there. No, yeah, it's capacitor, green cap right here. So this green cap, resistor, that, and then this one, which is an orange wire, which goes off to somewhere. I don't know, but it's buried over there somewhere. So orange wire. So orange wire there. And that's it. So there's 1, 2. No, there's another wire. Right there. Which goes to here. And goes to there's another wire. So that one goes over here somewhere. Alright, so there's that. And then this one's a mess. This one we got. Yeah, and that is the. What is that one? The triangle. Triangle's there. So triangle, empty, half circle, and I'm sure that's the square it is. So this one we have the square down here in this corner, which goes to 1 wire, which is going to this guy right here. This one. Which is, yep, that's the square going to that wire. And then we have the top one, which is the triangle. Triangle is going to another wire, which is looped, going right here. Yeah, right there. So triangle goes to that one, and then I don't know what that one is. Nothing, empty. So the empty one goes to this wire. It goes to two wires. That's it. Two wires. One goes to right there, which is this wire right here. It goes down here to the vertical output tube. Pin 2. So that goes to pin 2, the vertical output. And that one goes to the linearity control up here. It's this wire right there. Okay, and then the bottom one goes to this another, maybe a 68K resistor. Yeah, I think that's 68K. And then it also goes to another wire. Which is going to, looks like it's going to, where in the hell is it going? Not that one. There it is. It's this wire right here, I'm pretty sure. Which is going to this control. Alright, so that's the vertical. The one that's bad, vertical size, is going to that point there in a 68K resistor. Alright, and that's it. That's it for the caps. So we've got the caps documented 9 minutes later. Well, capacitor number 1 has been removed, which is this one here. Zenith original too. So I got to get up those values. So here's what I want to do. One of them is a 40, which pretty sure, let's see, 40 was half circle. Yeah, which is here. So the 40 goes off the main B rail, so I'm good with that. The other two are 20s, and then there's a 40 at, what is it, 50 volt? 25 volt. So that's a little tiny radial cap. So I could put a little radial cap in here, 47 UF 25 volt in there, off of the ground to this pin, because that's where it goes. Because what I did was I pulled these 3 wires out, and I'm going to run one new wire up to this sand resistor, because I got to replace it anyway, so I got to clean off that lug. So I'm going to run all that down, and then I'm going to add the two 20s here, 1 and 2, so there'll be one from this point here to ground. These two are ground, so you'll have a cap here, then we'll have a cap from here to here, and then the 10K resistor, which is right there, will go from here to here. So it'll fill out down in this area, and it'll free all this up, so I only have to have the one cap there, and then I gotta get the rest of them out. Alright, so now that I got this capacitor removed, I gotta get the next two out. So then comes the part of figuring out how I'm going to mount the new ones in there. Like I said, I already figured out I'm going to put at least 3 of them over here, so that's taken care of, but there's still one that has to come back over here, and there's a bunch that have to come back in here. And I don't know if I'm going to have the room to mount the terminal strips to be able to do that, so I'm trying to figure out exactly how that's going to work. But I do have another idea. It's a little ugly, but in this case it might work, and that's these here. Back when Radio Shack was closing, I got a bunch of stuff. You can see they marked out the barcode. PCB kit round. So I bet you I can take these, they're all different sizes, so at least 1, possibly 2 of these up here, and just put them on the top side and just mount them through and solder them to these holes as a ground point. Then I can feed the capacitors from the top side and solder them down, and then solder the wires to the cap, and just use this as a mounting base. Now, I've seen other videos where they make modern reproductions of these that fit the old capacitor bases, where you could solder new caps on top, and attach the wires to the lugs. I don't know what they're called and I don't know where to buy them yet, but I remember seeing that. So, but I don't remember seeing a link. Nobody posted a link anywhere where to buy them, but in the meantime, I have these, which should work. And also, I'm going to need 3. I only probably possibly have 1 or 2 that'll fit. And that's fine, because then I can actually cut up the rest of this and just kind of like mount it in there somewhere. Like I said, it's going to be ugly, but the 2 of them are hidden behind the yoke, so you're not going to see it anyway. And then we got this can on top, so anyways, who cares? Alright, so I decided to start in that section down there. So, I ran a new wire, which this new wire, I pulled all the old ones out, I ran a new one, which is going to go where the sand resistor is when I get the new resistor in. Then there is the caps. There's 3 caps here, 3 of the 4. Well, I moved them down here. Now, they're supposed to have 2 20 microfarad at 450 volts. Well, I don't have those, so I did a 10 and a 33. The capacitance is nearly equal. Even though it's slightly different across the pi filter, it's going to change the tuning a little bit, but for an audio circuit, it's not really going to matter that much because it's just acting as a filter anyways. I wanted to put the 33 on the end closer to the rectifier and then the 10 over here, but because of the physical size differences, that wouldn't fit there, so I did it the other way around. But now my 12K is across the 2 points. I have my 1 cap there and my other cap here. The only thing left to do now is put in the cathode bypass capacitor, which is a 40 microfarad at 25 volts. So I'm going to use a 47. And Radio Shack to the rescue again. 4735. That will fit across this resistor between here and the ground lug, which is right there. Got the capacitor installed for the cathode bypass. It's all in the circuit now. Wires ran, all that's ran. Also, I removed this capacitor here to get it prepared for the new one because I need to get it all out of the way. And I got the sand resistor all clipped out. I'm still waiting on the parts to arrive. But I went ahead and got these little circuit boards out. So I'm thinking I could probably use something like this on the opposite side and just solder down the lugs and just put the caps through this, maybe. I don't know, we'll figure it out. But so now that I have the 2 capacitors out, I figured it might not be a good idea to test them and see where we are. So okay, capacitor number 1, which is 40, 20, 20, and 40. If I'm not mistaken, I think that one was the one that was here. So let's do some tests real quick and see how bad these actually are. 51, so that's leaky. So let's do the next one here, the triangle. So it might be alright. So let's do the next one here, the square. 30. So this one isn't terrible. I'm sure it's leaky. Yeah, that's leaky for sure. So there's that one. So the one I just pulled out a minute ago, let's check that one. So let me start with one where there's a lug, because I broke the lugs off. 521 nanofarad. No, that's open. So let's check the one next to that. Open. Let's check the one next to that. That's pretty bad. Open. And then the 4th one, which is right here. Open. So yeah, this one's open. This is let's see, that's 15, 15, 30, and 40. So that tells me that this guy being in the middle here, there's all this other additional circuitry. So that's why we have those hum bars in the screen when we brought the vertical circuit back. So All right, so we know that that capacitor is definitely bad. I mean, no surprise there. So now, literally, I'm just waiting on parts. So I think at this point, we, we pretty much reached the conclusion of this part of the video, this part of the installment, because I mean, I can't go any further than where I'm already at. And I could pull this cap out, but I don't want to do that just yet, because if I start doing that, then I'm liable to forget where half of these wires go, and I'm already starting to forget where half of these wires go. So the parts should be here in a couple of days. I've ordered from various different sellers online. The Mauser order, I think, is going to be arriving today, but I still need the terminal strips and all this other stuff. So, in the meantime, thank you for watching. If you got a comment, please feel free to leave one, and don't forget to hit the like and subscribe and all that fun stuff. So, hopefully, you're enjoying this series. Until next time, guys.